Good morning, good afternoon, good evening. Thank you so much for being here. I hope you're doing well, staying safe, and having a great Ignite. My name is Premal Shah. I'm a program manager in the Azure Databricks team out of Redmond, Washington. And I'm super excited today to talk to you about how to manage your machine learning lifecycle using Azure Databricks and Azure Machine Learning. So let's get started. Welcome to the session on managing your machine learning lifecycle with Azure Databricks and Azure Machine Learning. It's great to have you here. My name is Premal Shah, and I'm a program manager in the Azure Databricks team. For the agenda today, we're going to walk through the machine learning lifecycle and its challenges, followed by how is the ML experience on Azure Databricks. And what I want to do is walk you through how Azure Databricks helps data scientists build models. We will then do a quick tour of MLflow, which is a very, very popular open source end-to-end machine learning lifecycle library. We will also then talk about the Azure Databricks and Azure Machine Learning and sort of how MLflow plays into that. And finally, I'll follow up with a demo to bring sort of all the concepts together. The machine learning development, unlike software development, has its set of challenges. If you look at a typical machine learning lifecycle, you have data preparation that has to be done, a bunch of data prep tools that have to be used, and you want to make sure that the right set of data is at hand for you to be able to build models. Now, unlike software development, where you conform to a functional specification and sort of a cause and effect relationship, in machine learning, your goal is to really optimize a metric and arrive at the best model. In order for you to do that, you need to try a variety of techniques and tools. In addition, the quality of a model will depend on the quality of your data. The higher the quality of your data, the better will be your model. Also, you need to think about model parameters like hyperparameters, and quickly it leads to an explosion of combinations for you to be able to arrive at the desired model. Now, all of us are familiar with the myriad of software tools out there. And as a data scientist, you need to make decisions on which tools and frameworks to use. This further complicates the process. Now, this is the easy part. Once you have a model, the tough part really is how to deploy those models to production. How do you manage your models? How do you deploy to different surface areas like the edge, for example? Now, once you have a model in production, that's not the end of it. How do you sort of monitor the model? And how do you ensure the model continues to give you the accurate and desired results as data is drifting? And that your model continues to meet the SLAs of your customers. And as you might have guessed by now, all of this is a cycle. And on top of it, as an enterprise, you would want governance, scale, and security. So as you can see, the whole model machine learning development is a hard and complex process. For the next couple of slides, I wanted to quickly walk you through the basics of Azure Databricks and Azure Machine Learning before we actually jump into the integration. Azure Databricks is a fast, easy, and collaborative cloud-based analytics platform. The nice thing about Azure Databricks is it's a unique first-party Azure offering and is the result of a strong partnership with Databricks, who are the world leaders in Spark. And this partnership brings you the best of Microsoft and Databricks. Basically, we strive to follow three key philosophies. We as a team want to ensure that our customers are able to achieve the highest level of productivity using the platform, and they really don't have to worry about infrastructure issues and other complexities, and can focus on their applications. Secondly, we have a comprehensive collaboration platform for data scientists to be able to work with each other in teams to develop their machine learning applications. Secondly, security is paramount to enterprises like yourselves. And we want to make sure that we offer you the level of security that you as a customer have come to expect from Azure. And this is an area that we spend a significant time on. Finally, a big data system needs to scale. And one of our goals is to enable capabilities such that the platform scales with you. We have features like auto scaling, where you can start small and grow big. And the platform scales dynamically according to your workload needs. Now, this also saves you costs because you only use the resources you really need. So this is an amazing feature that allows you to get the best out of the platform. Over and above being a first-party service, we have closely integrated with other core Azure services to offer you a comprehensive end-to-end platform on Azure. Azure Machine Learning Service empowers you to bring AI to everyone with an end-to-end, scalable, trusted platform on Azure. Again, we have three philosophies here. One is you want to boost your data science productivity. So we want to really meet data scientists where they are. We have Python pip installable extensions for Azure Machine Learning that enables data scientists to build and deploy machine learning and deep learning models. And they're now available for things like computer vision, text analytics, and time series for forecasting. Now, a couple of slides back, we saw the importance of experimentation. And given the number of combinations you need to generate to arrive at the best model, hence there is a need for a platform that allows you a rapid rate of experimentation. You can, through Azure Machine Learning, you can rapidly prototype on your desktop, then easily scale up on virtual machines, or scale out even using Spark clusters. You can proactively manage model performance. You can identify the best model and then promote it using data driven insights. And finally, you can collaborate and share solutions using popular Git repositories. The most important part about Azure Machine Learning is its capabilities around comprehensive model management. You can deploy and manage your models everywhere. So you can, you have Docker containers to deploy models in the cloud, on premises, or at the edge. So there's a great amount of flexibility in how you are able to leverage your models. You can also promote your best performing models into production through the Azure Machine Learning integration with Azure DevOps and what is known as MLOps, and then retrain these models when the performance degrades. And just like Azure Databricks, Azure Machine Learning also natively integrates with other first-party Azure services as well. To level set, let's look at a typical machine learning lifecycle process. And this could be just one representation. There are other variants of this as well, as you know. You first prepare data and use feature engineering techniques to get data to a state from which you can start building a model using an idea of your choice. Training and testing a model includes experimentation as you're trying to arrive at the right model. Then you register a model in a model registry so that your model is reusable across your enterprise, across different applications. The model registry then offers you capabilities like discoverability to retrieve models that might be of interest to you, and also things like model versioning. From the model registry, then, you can promote the best model to production. And then, of course, you need to monitor that model. Now, all of this is a cyclical process, as we have seen, where models will need to be retrained and redeployed to consider things like data drifting. Again, this is a complex ML lifecycle that you're trying to build. I want to spend the next few slides on how Azure Databricks helps data scientists achieve their goals of building machine learning models on Azure Databricks. You must have seen this famous slide before, and this is a famous paper from Google that appeared at NIPS 2015. It's a very interesting paper in which they conclude that only a small fraction of real world ML systems is composed of the actual machine learning code, as you can see from the small box in the middle. And as a starting data scientist, when I started my journey in this area, I used to actually think that all there is the ML code, and I learned it the hard way that the surrounding infrastructure is so important, and it's vast and complex, and you need all the infrastructure components to offer capabilities and really a single platform for you to build your end-to-end machine learning applications. And this is where I feel Azure Databricks really shines, in that it provides you with a simple and collaborative way to realize all of the surrounding complex functionality and components that you need to build your model. And we will talk more about that in subsequent slides. So, how does Azure Databricks helps data scientists? Now, to improve data science productivity, we offer the machine learning runtime in Azure Databricks to train your models. The machine learning runtime has several different aspects which are very important. First is that we package and optimize the most common machine learning frameworks in the machine learning runtime. With every machine learning runtime release, we package up the latest releases of these frameworks. We ensure that these frameworks work well together, and in many cases, these packaged frameworks will be more performant than the open source version. But that is only the beginning. We also offer built-in optimizations to do distributed learning, and we package Horoword as part of the ML runtime as well. With Horoword, you can easily take a single machine learning piece of code and distribute it across machines. For example, you can take a scikit-learn model and distribute that to thousands of machines to train your model on large datasets in an efficient manner. We also package hyperparameter tuning and machine learning capabilities, auto machine learning capabilities for you to be able to find the best parameters for your model and also track these experiments with MLflow. Last but not the least, we have Conda to manage our machine learning runtimes. This allows our customers to bring in conda.yaml files and we can recreate their environments for them. Let's continue to look at different ways in which Azure Databricks helps data scientists. You can do distributed machine learning over really large sets of data using Spark ML Lake. And as mentioned in the previous slide, also migrate single node to distributed code easily with few changes. The Colas project is really interesting. It makes data scientists productive while interacting with big data where they can literally just bring in their pandas code and have it work on Spark with minimal changes. They can be immediately productive on Spark as well as have a single code base that works on both small as well as large data sets. Pandas UDF, which you will see later in the demo I'll show you how it's used, is very useful for vectorizing scalar operations, like for example batch scoring. And it substantially improves the performance and usability of user-defined functions in Python. Now, you can write your notebooks in Python, R, Scala, and SQL, and hence provide a lot of flexibility. You can also, in fact, intersperse these languages in the same notebook, where you can specify which language you want to use at a notebook cell level. Databricks Connect meets data scientists really where they are at the idea of your choice, and you can use Databricks Connect to connect to Azure Databricks clusters and run Spark code. With Delta Lake, you can enforce that high quality data lands in your lake and also its enhanced query capabilities, which is very, very useful for a data scientist. Delta Lake time travel ensures that all the transformations and experiments that you perform on your data are trackable, reproducible, and reversible. We also have several great capabilities coming up where you can do source control of an entire project instead of just notebooks. With hosted Jupyter Lab, it enables data scientists to use their familiar local environments in Azure Databricks. The next few slides, I want to take the opportunity to introduce MLflow and integration between Azure Databricks and Azure Machine Learning. MLflow is an open source framework for the complete machine learning lifecycle that was developed at Databricks. It has become extremely popular. And in fact, what Spark took 3 years to achieve, MLflow has achieved that in just 1 year. It was announced at Spark Summit earlier this year that MLflow will now be part of the Linux Foundation, which will further help it progress. And at this point, it has 200 contributors and almost 2 million downloads a month and continues to accelerate in adoption. MLflow has several components. The most prominent among them is the tracking component, which allows you to capture runs and experiments as you're looking for the best model, and all the metrics and artifacts that are produced from these runs. All of these experiments and runs can be viewed from within Azure Databricks, and these can be shared with others and also access controlled. MLflow projects is a packaging format which allows you to package up your data science code in a reusable and reproducible way. You can also execute MLflow projects remotely on Azure Databricks from your desktop. MLflow models is a general model format that allows you to package up your diverse models in a common format. And the good thing about this is that it allows your models to get deployed using a wide variety of tools that understand that general format. And that all this happens in a common and consistent manner as well. Now, a recently released component is the MLflow registry, which is a centralized model store which allows you to manage the lifecycle of an MLflow model. It provides features like model lineage, model versioning, and also supports things like stage transitions of models to move them from staging to production. As mentioned in the previous slide, this common ML flow model format is really the magic behind different tools being able to deploy these models. One of them being Azure Machine Learning. And MLflow provides you also with utilities to make these deployments much easier. You can use batch and streaming scoring capabilities in Azure Databricks, or you can deploy the models in Azure Machine Learning for real-time scoring, which is the integration that we'll talk about shortly. Now let us all bring all of this, whatever we've learned so far, to talk about the Azure Databricks, Azure Machine Learning integration and its benefits. So using MLflow as the glue, we have combined the best of Azure Databricks and Azure Machine Learning. So you as a customer can continue to use MLflow APIs, which are super popular. And under the hood, what we're doing is we are calling into the AML APIs to make sure that all these runs are logged into an AML workspace. And this, all of this would hopefully be clear when we go through the demo as well. So what this integration and better together story allows you to do is you can train your models now on Azure Databricks using all the capabilities that are offered. You can then, while you're building your model, you can log experiments and models in a central Azure Machine Learning workspace. So you can use Azure Databricks, you might be using just an Azure VM. All of these runs and experiments are then collected in a central place. And all of this, of course, are audited so that as from a compliance perspective, you know exactly who did what. Then you can deploy these models in Azure ML, as I mentioned before, across several surface areas. And then you can manage your models. You can do things like, model drift detection, model retraining, model redeployment, model monitoring. So all of these, you can leverage the cool capabilities of Azure Machine Learning from a model management perspective as well. So if you look at the machine learning lifecycle on Azure Databricks, you prep data using, as I mentioned, Delta Lake, so that you have high quality data coming into the lake. You do feature engineering on Azure Databricks. You build your model, and while you're building your model, you're using, Azure Databricks runtime for ML with its pre-packaged frameworks, and using the ML flow project and tracking. And then you're finally you're deploying the model through this common ML flow model format that I referred to. And this allows you to integrate with Azure Machine Learning as well. Now, this is the lifecycle on Azure Databricks, but there is more to the ML lifecycle. Typically, an ML lifecycle would just involve, you train a model and you push it to production. But what the integration with Azure Machine Learning allows you to do is, as I mentioned, you can, while training the model on Azure Databricks, you can track experiments, track hyperparameters in Azure Machine Learning. You can then validate the model. So you can track the model efficiency. You can compare it with other models. So if you came up with a new model, you want to be able to compare it with a model that's already in production and then deploy it if your current model is more efficient than the previous model. Once you deploy a model through a container to different surface areas, you want to then be able to monitor the model, you want to detect drift, you want to make sure the model are retrained, and all of this again is a cyclical process. And Azure Machine Learning with its ML Ops capabilities and integration with Azure DevOps offers you these capabilities to make sure that the right model is getting pushed to production. Let's now go ahead and see a demo to bring all of this together. As part of the demo, I'm going to show you a notebook that walks through how we can track runs and deploy models in Azure Machine Learning from Azure Databricks using the open source MLflow APIs. So customers love three things. One, they love training models on Azure Databricks. They like the model management capabilities of Azure Machine Learning, and they like doing it through the MLflow open source APIs, which are very popular. So the basic setup here is we've created a very simple way to do this. All you need to do is literally link an Azure Databricks workspace with an Azure Machine Learning workspace. And once that is done, any calls to ML flow will be intercepted, and all the runs and metrics will go to the Azure Machine Learning workspace to which you linked and to ML flow within Azure Databricks. So tracking will be done at both places. So let me kind of show you on how to link a workspace. So I have here a new workspace that I created. As you can see, we've introduced a new button here that when you say link Azure ML workspace, you can go in there and sort of link the Azure ML workspace. And once you do that linking, MLflow recognizes the fact that you want these metrics and runs to be also logged into an Azure Machine Learning workspace. So coming back to this notebook, which I've already linked, I have a very simple use case to show you. It is basically IoT data that is in a delta table called sensors, and all it has is it has 5 sensors per device, and based on the value of 4 sensors, we want to predict the value of the fifth one. So really simple example, but just wanted to use this to sort of demonstrate how the integration is working. So first thing I do is I set up an experiment. So I give it an experiment name here, and this experiment sort of appears here, as you can see. So that's the first thing I sort of do, just to define it, because that's where all the runs will be collected. Now I have this random forest regressor Spark ML lib model that I'm going to use. And notice these calls that I make here. MLflow.log metric means I'm logging what MSC and what R2 I'm getting out of the model. But then I also want to finally log model. So when I do this, because I've linked the two workspaces, that means that all this metrics will go to an Azure Machine Learning workspace. So I already had some prior executions of the notebook. So let me just go ahead, go to the Azure Machine Learning workspace, and sort of show you the experiment. So I already ran a few experiments here. As you can see, just by linking the two, all the runs have appeared in an Azure Machine Learning workspace, which was linked. I can go into any one run. So as you can see, it logs the all the metrics here. It also logs the default tags that MLflow assigns. Of course, you can add custom tags also, and so that they would appear here, so you can filter and sort of search by that as well. So if I go to the run here, you can see that it captures some more information. It captures the source, so it captures this where this run was logged from, which notebook it was logged from. So it has a lot of good information here that you can actually use to understand better as to what happened. So let me go back to the notebook, and then what I have is I have a scikit-learn model that I'm running on the same data set to construct basically 3 models. And what I'm doing is that I'm varying the max depth hereby, and so I get 3 models, and for each model, I'm sort of logging the model and the metrics for each one of them. So I'm just going to run this cell just to kind of show you. As you can see, previously we saw a few runs here, and now we should see a few more runs getting added here. So I go here, I just run this cell. So if I go back to my Azure Machine Learning workspace and refresh, so as you can see, 3 more runs got added, which is the scikit-learn models. Notice that I also, what I've done here is I've taken the last run ID. So MLflow has this concept of active run. So I've just kind of picked the last run here and given it a run ID, and I'll show you later why I'm doing that. Also notice that I can go to the experiment that I defined here, and I can see that all the runs are also logged in the MLflow UI in Azure Databricks. So it's logged at both places. And you can go to the Azure Machine Learning workspace and deploy the model from there. And that's what we'll show you later. Go back to the notebook. So I keep going. I have now the Python models. I have this run ID. Now what I want to be able to do is I want to use that model for batch scoring and as a request response web service. So for request response web service, I have to deploy it to Azure Machine Learning because that's sort of the real time request response scoring that I want from Azure Machine Learning. So for batch scoring, as I mentioned, I this is taking the last model that I built using the scikit-learn. So it's just randomly picking the last one. Then I'm using this Spark UDF. If you remember in the presentation earlier, I mentioned about optimized Spark UDF. So all I'm doing here is I'm doing some batch scoring. I'm taking the values of the sensors and then just adding a prediction here. As you can see, I'm just picking sort of one particular device here, and then you can see that the sensor 5 is pretty. I'm not running each of these cells. Some of them take a little bit of time, so I just want to show you the code and what it looks like and what it does. So it would predict, and here you can see the predictions for for this particular sensor. Now once I'm done with this, what I want to do is now I want to deploy that model, the scikit-learn model, onto AML. So I come here and we have added this new call. As you can see, it's a very simple-minded call. And the first thing I need to do is I need to get this workspace object. And the workspace object is denoting as to which workspace should I be deploying this particular model. So if I go back to, there's an init script here that specifies sort of the workspace details. And then I go back, and then when I say from config, it is actually going to read the workspace details from that configuration file. Just go back here. And now when I execute this call, it is actually creating an image, and it's deploying it as a container onto AML. So if I go back to the Azure Machine Learning workspace, and if I go to models, for example, as you can see, I've run this notebook multiple times. So I have like 3 models that I've deployed. I can click on any one of them. As you can see, it gives you a lot of information about the model itself. I can go to my artifacts. And if you remember, we talked about the MLflow common model format, and this is what this is. So this is a pickle file. This is the format of the actual the configuration of the model, so that any tool can actually deploy this, which understands this generic MLflow format. So I've deployed this model as a web service. Once I deploy it as a web service, I have some JSON data here. So I'm just giving it, the random 4 values for the sensors. And what I'm expecting from this is the, is the value. So I have the scoring URI, there's a, the service that I created. So notice that I get back a service and I get back a model. And the service I created, I get back the URI, and that's what I'm using to actually score. So if I run this with values, it will come back with giving it back a response. So this is how the end-to-end flow works for AML and Azure Databricks. As you can see, it's very, very simple. Of course, we are working on this. We're going to make it simpler. But a year back, you had to do a bunch of things, but now it's become much more simpler. There's one more thing I wanted to show you is if you go to clusters here. This is the cluster that I did, and you notice that it has got the ML runtime, which I was mentioning earlier, that the ML runtime comes pre-packaged with MLflow libraries and a whole bunch of other frameworks. And that's why you notice that I didn't have to do any kind of installation of MLflow or scikit-learn. It just comes with the ML runtime. So that's how I wanted to show you how the integration between Azure Machine Learning and Azure Databricks works. To summarize then, what we saw is we can integrate Azure Databricks with Azure Machine Learning using MLflow as the glue. You use Azure Databricks to prepare data at massive scale. You can leverage the latest library and frameworks through the dedicated machine learning runtime with pre-built optimizations. You can do distributed deep learning, distributed classical learning. You can use the collaboration features of Azure Databricks to create models. And then finally, you use MLflow integration to have a common and a central place to store all your runs and a central model registry across all of Azure, no matter which application you're using. And it gives you sort of a combined view of all the activity that you're doing from various sources, whether it be a VM or whether it's from Azure Databricks or maybe even some other application. And finally, Azure Machine Learning allows you to package and deploy models for real-time inferencing. You have critical abilities like model monitoring and the ability to detect data drifts and then to redeploy models to make sure that models continue to be current and accurate. And finally, the integration with Azure DevOps allows you to implement MLOps type pipelines. So you can create CI/CD pipelines to deploy and to make sure that the right models are going to production. Thank you for watching. I hope that was useful to you. Take care and stay safe.